Measures for the protection of Venice and its lagoons. The dramatic flood of November 1966 assumed a symbolic significance. The survival of Venice and its lagoon can't be guaranteed unless serious measures were taken for its protection and preservation. Since then, the interaction between sea level rise and high waters, erosion and pollution has been tackled with many years of studies, experiments, engineering design, and works. By means of specific legislation and thanks to considerable funding from the Italian government. In 1984, with Special Law 798/84, the Italian government appointed a state concessionaire, the Consorzio Venezia Nuova, to implement all measures needed to protect Venice and its lagoon, to restore the hydrological equilibrium of the lagoon, to block and reverse the process of environmental deterioration, and to eliminate its causes, to reduce the height of tides within the lagoon, to protect the urban centers from the devastating effects of flooding. All this means restoring and conserving the lagoon ecosystem, as well as monitoring and managing its evolutionary trends. In the context of its commission, the Consorzio Venezia Nuova appointed Tecnical SPA to perform the definition of the intervention scheme, the planning and supervision of all field investigations and monitoring campaigns, the planning and coordination of all specialized studies performed by others, the planning and supervision of mathematical and physical models performed by specialized laboratories, the preliminary and final design of all works and interventions. The measures implemented or under implementation for the protection and preservation of Venice and its lagoons can be grouped as follows: physical protection measures, environmental restoration measures, special projects and measures. Physical protection measures. Local defenses of historic centers in the lagoon and of coastal settlements. Mobile flood control barriers at the 3 entrances of the lagoon. Reinforcement of the coastline. Restoration and reinforcement of the breakwaters at the 3 entrances of the lagoon. Local defenses of historic centers in the lagoon and coastal settlements. An integrated system of sea defenses has been planned to protect Venice from high water, which provides for localized physical defenses of the insulae, or groups of buildings surrounded by canals, for tides up to 1 meter. Mobile floodgates at the lagoon inlets, which will come into operation when the tide exceeds 1 meter. Today, an average 7 times per year. Schematic view of an intervention. Palestrina before, Palestrina after. Mobile floodgate control barriers at the 3 entrances of the lagoon. The exceptional tides exceeding 1 meter are controlled by the temporary closing of the 3 entrances of the lagoon. Lido, Malamok, Chioggi. According to the special law for Venice, the type of barrier adopted must comply with the following requisites, and must not include aerial or above-ground structures, and must fit well into the lagoon landscape, and must not diminish the natural tidal exchange between sea and lagoon, and must not interfere with shipping, port activities, and fishing. Out of the more than 12 types of barriers studied and evaluated, the type selected for this case is the oscillating buoyant flapgate. Floodgate operating scheme. Floodgate in operation. Floodgate cross-section. Boca di Porto di Malamok. Boca di Porto di Lid. Sierra di Pratoi. Porto Refugi. Squaglia. Boca di Porto di Chilocia. Components of a barrier. Section of a barrier. View of a barrier in operation. The full-scale prototype. Reinforcement of the coastline. The coastline is affected by a predominant erosion process caused largely by the unintentional results of the works carried out in the past, namely the seawall defenses called marazzi, constructed in the 18th century, the long breakwaters at the 3 entrances of the lagoon, constructed in the 19th century. Depending on local conditions, the type of remedial works include confined beach nourishment, anti-infiltration diaphragms, restoration of old seawalls, reconstruction of sand dunes. The plan covers 60 kilometers of coast between the Piave and Attica rivers and is the largest ever carried out in Italy. View of Palestrina coastline. Cavallina coastline. Reconstruction of dunes. Reconstruction of the main morphological units. Further to the increase in depth of the lagoon due to subsidence and a static rise, human activities like the diversion of rivers and the construction of the breakwaters at the lagoon entrances have inverted the silting tendency too and triggered an erosion process that is transforming the lagoon into a sea environment. Salt marshes. 1930, 72 cubic kilometers. 1990, 47 cubic kilometers. Comparison between 1810 bathymetric readings and the most recent ones. The measures undertaken to restore the lagoon's natural morphology include reconstruction and protection of mudflats and salt marshes, dredging of lagoon channels, renaturalizing and reclaimed areas, restoring and reinforcing the shorelines of a number of islands in the lagoon, reconstructed salt marsh, environmental restoration measures, reconstruction of the main morphological units, arrest and reversal of the environmental deterioration process. Arrest and reversal of the environmental deterioration process. Pollution in the lagoon is caused by an excess in nutrients, nitrogen and phosphorus, an organic substance coming from agricultural, industrial, and urban sources in the drainage basin and the lagoon. Pollutants and heavy metals coming from the Marghera industrial area. Today, the following pollutants are discharged into the lagoon. Phosphorus, 800 tons per year. Nitrogen, 7,000 tons per year. BOD, 4,700 tons per year. Pollution-induced environmental deterioration is manifested as follows. The number of animal and vegetable species has diminished. The growth of macroalgae has proliferated abnormally. The water has become increasingly turbid, thus reducing the growth of eelgrass, the main natural protection to erosion. The restoration of the trophic equilibrium in the lagoon can only be achieved by reducing the overall pollution load by 70%. To do this, all known sources of pollution need to be kept under close control in order to enhance the natural self-purification capacity of the lagoon. As well as the development of water treatment plants in the drainage basin, the following measures have been implemented in the lagoon. Securing and developing abandoned dump sites. Transplanting eelgrass to consolidate the lagoon beds. Monitoring and harvesting macroalgae. Treating polluted sediments. Restoring industrial channels and quays in Marghera. Creating wetlands on the edge of the lagoon for phytopurification. Securing dump sites. Isola della Tres during rehabilitation. Wetland for the phytopurification of wastewaters. Plan for the diversion of oil tanker traffic away from the lagoon. The proposal under study includes closing down the terminal of oil pipeline in Marghera, which is at present supplying the refinery of Mantua, reorganizing the production and transportation of oil products in the whole Adriatic region, denying access to the lagoon to all those ships that not fully conform to international security regulations. With these actions, the oil tanker traffic in the lagoon will be reduced by 20%. Illuminated corridor to guide ships into the lagoon in poor visibility conditions. State of implementation of the program. The implementation of the measures described here above started in 1987. Today there are 25 fully operating work sites in the lagoon and 10 monitoring campaigns underway. Up to December 31, 2003, the final balance of works completed is approximately $20 million. The total cost of the program, which is forecasted to be completed by 2010, is in the range of $5 billion. Tecnital, which is the sole engineering firm entrusted by the Consorzio Venezia Nueva with the planning and design of these works, has spent more than 3.5 million hours of specialized engineering on this project and has developed a particularly valuable know-how in this field, which can be now fruitfully applied in many similar cases around the world. The total value of Tecnital's engineering contract is in the range of $180 million.